Hello and welcome back. We're going to talk about characters and strings in this segment. We talked about the char data type very early in the early segments, and here's the declaration of a char. You can say char if you want to. It is the smallest data type in C. It comes in two flavors, signed and unsigned. If you don't say unsigned, then the default is that we have a signed char. That means that you can have negative and positive values in a char variable, and the range of values you can store is negative 128 to positive 127. If this were an unsigned char, the range of values would be from 0 to 255, which is the range of values you can store in 1 byte of space. If you put a character inside of single quotes, you have something called a char literal. And what actually is being stored in the variable ch is the ASCII code for the character A, which happens to be 95, so these two assignment statements are effectively the same. You can scan a char from the console using the %C sequence, and there's also a simpler way that you can read a character from the console called getChar, and it returns the character that's typed at the console. And you can use printf to output a character to the console, and you can use a corresponding function called putChar. When inputting characters from the console, you need to be a little bit careful with the end-of-line characters. So someone who's entering a character at the console types one character and then hits enter, and the enter key generates the characters \r and \n, which is line feed and carriage return. Here's a small loop that will eat up the unwanted characters. If you're just trying to get the character that the person has typed, not the carriage return and line feed characters, then you make a little loop that will eat up all of the characters until it comes to the carriage return character. So it's a while loop that has a semicolon at the end. That means it does nothing, so you keep calling getChar until you have eaten up the excess characters that you don't want. Let's look at arrays of characters now, and the concept of a string in C. So you declare an array of characters the same as you would any other data type array, and this is not a string. You can initialize it by putting characters in single quotes, but the concept of a string in C means that there is a null character at the end. So this is an array of characters, this one that has 5 in it, but this one that has 6 is what in C convention we refer to as a string. The null character is \0, and it has numeric 0. And it's assumed that if you're going to treat something as a string, it will have that null character at the end. You have to be careful that you leave enough space for it. No one would do this because you can do it with double quotes. So in the C language, if you put something in double quotes, the null character is automatically added to the end. So although this looks like 5 characters inside of double quotes, it's actually 6 characters, including that null character. And when you want to make a string in your C program using the double quotes, you can do it using the pointer syntax as opposed to the subscript syntax. Remember that the name of the array has a pointer to the first character in the array. In C, anything inside of double quotes has the data type char pointer. That means that it's an array of characters and the last character is the null character. So to make this clear, let's look at a function that processes a string in C. We're going to look at a function called length that will count the number of characters in a string. The parameter data type is a char pointer. That means we're passing an array of characters, and the function assumes that there will be a null character as the last character in the string. So here's a picture over here on the right of the 5 characters and the null character, making 6 altogether. When we count these, we want to count that there are 5 characters in the string. So we start out by accepting a pointer to the first character, which is how you pass an array in C, and we make a loop that says while what's pointed at by the variable passed in is not equal to null, then we'll add 1 to the result, which is the counter, and we'll add 1 to the pointer. When we add 1 to the pointer, it moves the string pointer to the next character, and then we add 1 and move the pointer to the next character, and so on. And while it's not the null character, we'll keep adding 1 and then return the result. Okay, so here's a spec. We're going to go into the development environment and write a function that will take a car pointer, which is a string, and we're going to print out the characters in the string without including any spaces. So let's go into the development environment now. So let's look at this spec. We're going to write a function that takes a string, which is a car pointer, and print it out to the console without any spaces. And we're going to do this using pointer offset syntax. So here's an example call to the function that we'll write and what we expect the function to output onto the console. Okay, so I have the function started. Here's the function prototype. It doesn't return anything. It's called no spaces, and it takes a car pointer. And here's a call to the function. Something in double quotes is a car pointer, and here's the function that we're going to write. So what we want to do is to put the characters out onto the console. Okay, so let's output what's pointed at by str, and we want to do that repeatedly, so we'll make a while loop around it. While what's pointed at by str is not equal to the null character, which is the indicator that we've come to the end of the string. So we'll put out each character onto the console. And before we finish, why don't we see if this one does anything useful? What we're hoping is that this one will actually output the string as it was passed into the function, and it doesn't work. Okay, well, of course it doesn't work because we didn't increment the pointer. So we were outputting spaces, the first character in the string repeatedly, and not changing the pointer. So the mistake that I made was I did not use the debugger and watch what was going on. Let's recompile this. And now here's the string. We've stopped at the breakpoint. And what's pointed at by str? Well, let's put that in a watch window. It has the ASCII code 32, which is the code for space. And now if we walk through this, we will output a space onto the console, then move the pointer to the next character, which is H, or ASCII code 72, and output that one. Now we have an I. Okay, so this is working better now. I'm just hitting F10 as fast as I can. Let's go out to the console and see if it's doing what we expect. So far so good. And I'll turn that breakpoint off and just hit F5 and let it finish. So we do have a function now that will output onto the console whatever was passed into the function. Now we want to selectively output the character if it's not equal to a space. So if what's pointed at by the string pointer is not equal to a space, then we'll do the put car. Let's try running this just to see what happens without the debugger, and it seems to work. So it stops at the right place because the null character is in the string automatically because we use these double quotes. Okay, back in the slides now. Working with strings as an array of characters, it can be tedious, and there are many places for bugs. We saw one of them where I didn't increment the pointer. It's the kind of mistake that you will make when you're working with strings, and that's valuable for you to see. So here's a mistake. I allocated space for 5 characters, but what I assigned to it didn't leave room for the null character. What would happen if you pass this array of characters to a function that is expecting a string? Well, if the null character is not there, the loop won't know where to stop, and you will have some strange behavior. It will keep looking for a byte that has a 0 in it, and that may be immediate, it might work, or it might take a very long time depending on what was left over in the memory nearby where this array of characters was declared. Well, there are many standard functions provided to you for working with strings, and you can have access to those by including string.h at the top of your program. For example, string length, strlen, takes a car pointer, returns an int, and that will be the length of the string, not counting the null character. So you could write your own. That one we actually wrote on an earlier slide, but you don't need to. So there are lots of them. Here's one called string compare, strcmp, and it returns a negative number, a 0, or a positive number, depending on which of these two strings passed in comes first alphabetically. So it goes through each of the characters in the string and compares them, and the first one that it comes to that's different, it will decide whether the first parameter comes before the second parameter. Googling around a little bit to find out what all the str functions can do, they all start with str, is a useful thing to be doing before you write your own functions to manipulate strings. Sometimes you have to anyway, but you should look at the standard ones that are available first. So in summary, a string is an array of characters terminated by a null character. If you use double quotes in the C syntax, you will have a literal of data type car pointer, and the null character will automatically be added to the end of your character array when you use those double quotes. There are many functions that process strings, and they do it by looking for the null character. If there's no null character present, then the function will keep looking at bytes beyond the end of the array, and this is always a mistake. And string.h will contain the prototypes for many of the standard functions. If you include that, it will make those available to you, and you can manipulate strings using the standard functions. Well, playing with strings is a lot of fun. You can watch what's going on in the debugger all the time to make sure that you haven't gone past the end of your array and so on. And the tricky part is really just the null character at the end, which doesn't exist in other kinds of arrays. I'll see you in the next segment.